In this video, we're going to take a look at using Vertex Form to solve for x-intercepts. Let's start with an example problem. So, what are the x-intercepts for the graph y equals negative 2x squared minus 16x plus 18? So our first step is to convert this to Vertex Form. If you need extra help converting to Vertex Form, take a look at a previous video I did on how to do this. So our first step is to go ahead and write y equals, we're going to take negative 2 out and get our parentheses. We know it's going to be negative 2 times x squared. And then I like to think about the signs first. A negative times what will give me a negative for the negative 16x? That would have to be a negative times a positive. And then I know the number would have to be 2 times 8. So that would give us a 8x. I know after that I'll have a positive. And then I can put the positive 18 on the outside. Next up, we go ahead and set up our generic rectangle. We put x squared in the top left-hand corner. And then remember, you have to take the positive 8x and split it into the diagonal boxes. You're dividing it by 2 to get 4x and 4x. At this point, we can go ahead and fill in the outside of our generic rectangle. So how do we get x squared? That would be x times x. And then we would have x times positive 4 and x times positive 4 to get our 4x's. 4 times 4 would give us 16. And that 16 goes in the blank spot we have in the parentheses above. Now, that 16 is being multiplied by the negative 2. So on the outside, we have to do the opposite of negative 2 times positive 16 to balance the equation. So negative 2 times 16 would be negative 32. And the opposite of negative 32, positive 32. All right, from this point, we can go ahead and just simplify this and get our vertex form. So we got y equals negative 2 times x plus 4 squared plus 50. Now we're ready to go ahead and solve for our x-intercepts. Remember, if you want to find the x-intercepts, you just let y equal 0. Let's go ahead and clear up some space so that we can take a closer look at how we're going to actually solve for x-intercepts from vertex form. So one way to go about solving this is to think about how can we isolate that x plus 4 squared. Think about it if it was just a two-step equation where the x plus 4 squared is just replaced by n. What would we do to solve that two-step equation on the right? Well, the first step is we'd go ahead and subtract 50 from both sides. That would give us negative 50 equals negative 2n. So on the left side, that becomes negative 50 equals negative 2 times x plus 4 squared. On the right side, our next step would be to divide both sides by negative 2. So that gives us 25 equals n. On the left side, it becomes that. So the question is, what number do we square to get 25? And your first answer might be 5. So 5 could equal x plus 4. But wait, there's another option here that would also give us 25. And that would be negative 5. Because negative 5 times negative 5 is 25. So the way we show this is with a plus minus sign. Now we want to get the x by itself. So I'm going to move the positive 4 to the other side and get negative 4 plus or minus 5. I'll go ahead and turn that around into x equals. And when I go negative 4 plus 5, I get 1. And when I go negative 4 minus 5, I get negative 9. Remember, originally they asked us, what are the x-intercepts? Probably the best way to answer that would be that the x-intercepts are 1, 0, and negative 9, 0. Another strategy you could use to solve this is to think about order of operations, which a lot of us learned as PEMDAS. If we put a value in for x, we would do our parentheses first, then we would do our exponent, then we would multiply by the negative 2, then we would finally add 50. Well, if you want to solve for x, you can do the reverse order of PEMDAS. So, what does this look like? This means that the first thing we would do is look for an opportunity to subtract or add. So what did we do? We got rid of our plus 50. Next, you would look for dividing and multiplying. So what did we do in our equation? In our next step, we got rid of our multiply by -2 by dividing by -2. Next up, we did our exponent, which means we got rid of our squared here, which led to our plus or minus 5. And the last thing we did was dealt with what was inside the parentheses, which was x plus 4, and that just became a minus 4. And that's another way to think about how you can end up with your answer for x. Let's take a look at another one. By the way, at the end of this one, the answer is not going to be as nice as the one we just did. All right, so what is our first step? If you want to find the x-intercepts, you got to let y equal 0. In this case, f of x is being used instead of y. So there's our setup, setting it equal to 0. First step is I want to take that -40, and when I move it to the other side, it becomes positive 40. Now I want to get rid of that multiplying by 4. So I'm going to divide both sides by 4 and get 10 equals x minus 3 squared. At this point, what we're doing is basically taking the square root of both sides. So we would get radical 10 equals x minus 3. But be careful here. Remember, there's another answer. Negative radical 10 times negative radical 10 would also equal 10. So we'd have to have our plus minus sign in the front, always. All right, I'm going to go ahead and just switch this around to x equals, and when I move the -3 to the other side, it becomes positive 3 plus or minus radical 10. If I want to write what my x-intercepts are, they're going to look kind of weird, but the exact answer would be 3 plus radical 10, 0, and 3 minus radical 10, 0. Now, if this is a word problem, you would not want to give your answer in that exact form. It turns out that radical 10 as a decimal is 3.162. So if I convert this to a decimal answer, I end up getting 6.162, 0, and negative 0.6120. This would be the common answer that you would give for like a word problem. In fact, in a word problem, based on the context, there's probably a really good chance that your negative value actually wouldn't make sense for a word problem, so that the answer to the word problem would simply be 6 and 162 thousandths. Okay, why don't you go ahead and give this one a try. So write down this problem, pause the video, solve it, and then come back and check your answer. So anytime you want to find the x-intercepts, you can rewrite the equation and let y equal 0. From here, we got to convert this to vertex form. So I'm going to take out a 5 from the x squared and the 20x. So that'd be 5 times 4x, would give me 20x. I'll leave a space for when I'm going to complete the square. The negative 25 goes on the outside. Then I can go ahead and make my generic rectangle. My x squared goes in the top left-hand corner, and then I split my plus 4x's into positive 2x's. Now we can work on the outside of the generic rectangle with x times x for x squared, and 2 and 2 to get our 2x's. 2 times 2 will complete the square with a positive 4, and that positive 4 goes in our blank spot. Now remember, when we add that positive 4, it's being multiplied by the a value of 5. So we've got 5 times 4 is positive 20. What's the opposite of positive 20? Negative 20, which goes on the outside. All right, now we can go ahead and simplify this into our vertex form. Now, to start solving vertex form for x-intercepts, we would take our negative 45, and when that moves to the left side, it becomes a positive 45. Next step is to go ahead and divide both sides by 5, and 45 divided by 5 gives us 9. And then we're thinking something squared equals 9. Remember that something is going to be two possibilities. That's going to be positive or negative 3. Next step, I'm going to go ahead and switch this around and have x equals. So when I move the positive 2 to the same side as the plus minus 3, the positive 2 will actually become a negative 2 plus or minus 3. And that would mean my x-intercepts are, if I go negative 2 plus 3, I would get an x-intercept of positive 1, 0. And if I go negative 2 minus 3, I would get an x-intercept of negative 5, 0. All right, that's it. That's how you use vertex form to solve for your x-intercepts.